Okay, I just want to give you guys some feedback on the written homework and also talk about the exam tomorrow. So first the exam. So it's about 4 pages, and you can have 1 page of notes front and back, right? And I want you to staple the notes to your test when you return the test at the end of the period. The exam starts at 11:30. You can try to get there. Sorry, try it again. The exam starts at 10:30. That's what our class is at Hazel 305. There are office hours right before the exam, so that might be a good place to come. Our class starts at 10:30, so the exam starts at 10:30. You'll have till about 11:20 or 11:25 maybe, but get there if you want to get there at 9:30, that's fine. Or if you want to, it's a good place to stop by. I'll be in Hazel, it's the same room as our class. Okay. All right. So let's see a couple things on the homework, a couple problems that people had trouble with. On this first one, they want you to find the equation of this quadratic function. You know it has this form. There's a couple ways to do this. You know the y-intercept is -2, so you know c is -2. Now, one thing you can do is, this is the point -1, 0, this is the point 2, 0. If you just plug those in, if you plug -1 in for x and 0 in for y, you get 0 equals a minus b minus 2. And if you plug 2 in for x and 0 for y into here, you get 4a plus 2b minus 2 equals 0. So what you do is you get two equations, two unknowns. This equation becomes a minus b is 2. This one, if you divide by 2, you can write as 2a plus b is 1. And then if you just add these two together, if you add this equation here to this equation here, you notice the b's cancel, and you have 3a equals 3. You've done that before. So a is 1. And then if a is 1, b would have to be -1 for this to be true. So this is your answer. Now, a faster way to do it, I noticed some people did this. If you realize these are x-intercepts, folks, remember if x equals -1 is an x-intercept, then that means x plus 1's a factor. You can see that because if you set this equal to 0, then x would have to equal -1 or 2 for this to be 0, right? So if 2 is an x-intercept, then x minus 2 has to be a factor. So that's the slick way to do it. Now, how do you know what a is? Well, if you plug in 0, -2, you see that when x is 0, y is -2. So you plug in 0 for x here and here, and you have -2a equals -2, so a is 1. So you get the same equation. This is just factored. So this is a lot faster. So people did okay on that one. That wasn't too bad. This one was kind of messy. But this is an application of quadratic functions, and they're giving you the formula. So that's usually easier if they give you the formula. The first question is, when does it splash down? Well, it splashes down when the height is 0. So this is actually kind of messy. I bet you're going to have to use the quadratic formula on this. One thing I did first, you don't have to do this, but I divided by, or I multiplied both sides by -1. That just made the quadratic formula a little bit easier. -b plus or minus the square root of b squared minus 4ac over 2a. So one thing about tomorrow, if your work is clear and I can follow what you're doing, even if you make a mistake, I'm going to give you a lot of partial credit. So try to be organized in your writing, okay? Don't go too fast. The exam is not that bad. It's kind of what we've been talking about. Nothing on that exam is going to seem new to you if you've done the homework. So you just got to slow down and do the best that you can. Anyway, if you throw this in the calculator. Oh, by the way, a graphing calculator is required. No computers, no Desmos. I will have a few lying around in case someone wants to borrow one, but you should try to bring your own if you can. So another question is, it says when does it yeah, so it's not when, it's what is the maximum height. I wish it was when, because if it was when does it reach its maximum height, you just get -b over 2a, and you get 12.653 seconds. But the question is, what is its maximum height? So then you'd plug that plug this number, 12.653, into the function, and I get this. Okay. These last ones are some more applications. I'll probably, if you look at linear and quadratic, probably like 2 or 3 application problems. That's about it, a total of 2 or 3. Someone asked me how many questions are there? Somewhere around 12. I don't know exactly, but it's 4 pages, but it's kind of spread out. Like I said, nothing too surprising. Read the problems carefully. This is the one where you're given a piece of cardboard. Now this is a square. That makes it easy. So it starts off, let's call it x by x. We're going to assume x is the length of the square before you cut it. You're cutting 3 inches out of each corner and folding it up. So if you look really carefully, if this whole thing is x, and you're cutting 3 inches off here and 3 inches off of here, this little piece that gets folded up right here and becomes the bottom is x minus 6. So is this. And then the height becomes 3. So the volume is length times width times height, which is going to be this. And so this is what you get. Now, it turns out the best way to solve this is not to multiply it out, is to divide by 3 and take the square root. I'll let you follow this steps. If you just hit the pause button, you can see this is the answer. Make sure you answer the question. This one is the one everyone had trouble with. So everyone wants to know, is this on the exam? Well, I'd say unlikely, but this would be like probably the hardest problem. It's probably a little harder, to be honest with you. A little bit harder than what I put on the exam. I think you could do it. It would just take too long, okay? But don't worry about that one about the was it joint base Lewis McChord? Don't worry about that one. I'm not gonna put that on there now. But you should know how to do this. But it's a little tiny bit too hard. Maybe not too much. You cut the string at a place. Now, this first place where you cut it, you're going to bend into a circle. So let's talk about that. The circumference of the circle is the length of what you cut, right? But you want to know the area of that circle, because we're talking about the area of this plus the area of the square. So if you solve this for r, and then you get r is x over 2 pi, and then the area is going to be pi r squared. So if you plug in this in for x and simplify, you get this. This is the area of the circle. The area of the square is easier because you just take this and you fold it into 4 pieces, right? So each side is 56 minus x divided by 4. Anyway, you multiply it out. This is the hard part right here. You multiply everything out carefully. I just call this 1/16 on the bottom, and it's going to be this squared minus twice the product of x times 56 plus x squared times 1/16. If you multiply this out, 3136 over 16 becomes 196. 112 divided by 16 happens to become -7. And x squared over 16 is here. And then what you do is you actually group together this term here with this term here, and you get the LCD. I did a couple steps at once. When you group those two terms together, get the LCD, you get 4 plus pi over 16 pi. Why do you do that? Because you need to know the coefficient of x squared, the coefficient of x, because you're wanting to find where should you cut it to maximize the area, so you have to have negative b over 2a. b is going to be -7, so this becomes +7 over 2 times this. The 2 and the 16 cancel, and then when you flip this over, it looks like this, so this is what you get. And this is x. This is what people have had trouble with. This actually is x. X is the circumference, isn't it? So x is where you cut it. Well, I'm sure you guys will do well. I have confidence in you on the exam tomorrow. Just work hard and just do the best you can. I'm sure you'll pull it off. All right, maybe I'll see you before class and during office hours. Good luck, everybody.